If you work in IT, computer programming skills open up an incredible amount of opportunity. Being able to write scripts and programs that tell your computer to perform a task equips you with an invaluable tool. Not only does it make your work easier and more efficient, it can help you grow faster and advance further in your IT career. But how do you even start to learn a programming language like Python? How do you recognize when to tell a computer to perform a task? And how do you then write a program to actually get your computer to complete the task you want it to do? The thought of learning to write a program in Python can make you feel a whole bunch of emotions. Excitement, anticipation, that feeling of wanting to dive right in and get going. And also fear. You might ask yourself, can I really learn how to code, or do I have it in me? I'm here to tell you, yes, you can absolutely do this. Learning how to program can be scary and intimidating, but at the same time, it's really fun and really exciting. In coding, as in life, if we're going to get philosophical, the most rewarding work is usually a bit challenging, but ultimately well worth the effort. Of course, I'm able to say all this from experience, especially the cheesy parts. My name is Christine Rafla. I'm a systems administrator at Google, and I'm going to be your instructor and guide in this course. The role of a sysadmin can vary a lot from company to company, and even within different teams in the same company. I happen to work in the Corporate Identity and Access Management Operations team, which is a really long way of saying that we make sure that everyone is represented correctly, and if they need to access certain resources, they can. What I love the most about being a sysadmin is that the role has so many diverse functions. We handle loads of unique problems and edge cases, from tinkering with different systems to collaborating with other teams. I am always learning something new, so it's really hard to get bored. It all starts with knowing how to automate. If you're an IT support specialist, a systems administrator, or in a role somewhere in between, knowing how to get computers to do the hard work for you will set you apart from others in similar IT roles, and make your life much easier. Think about it. Would you rather manually deploy 100 computers on your own, or tell your computer to do it all for you, all at once? No brainer, right? Having a coding skill set can help you grow into more specialized roles, like a systems administrator, cloud solutions engineer, DevOps specialist, site reliability engineer, or who knows, maybe even web developer or data analyst. The point is, being able to write a program is an essential tool in your IT toolkit, and more employers are looking for these skills in the people they hire. If you've ever learned a new skill, like playing a musical instrument, speaking a foreign language, knitting, or skateboarding, you know that getting good at something new requires a lot of practice. For me, I love to learn new languages, and I'm proud to say I speak Spanish, Arabic, French, and I even know 10 words in Russian. Our world is shaped by the words and the languages we speak, and while some words may be unique to one language, you can always find similarities that help you learn and understand. Being able to connect the dots between cultures allows me to see things others might not. Kinda sounds like this applies to IT programming, huh? My point is, whether you're learning French or Python, it's never easy. You have to start small, learn the basics, and practice those until you master them. Only then can you move on to more complex and impressive stuff. And I'm here to help you along that path, along with my colleagues who you'll meet in later courses. We'll start slow, master the foundations together, and you'll soon be ready for more challenging stuff. So are you wondering why we filmed this course in a cabin on a lake in Canada? The truth is, we're actually in a game room at one of the Google offices in Sunnyvale, California. We chose a different themed office space for each course of the program just to mix things up, and I think I scored with this one. I should warn my manager that I'll be hanging out in this one well after the course ends because it's super comfy. By the end of this course, you'll understand the benefits of programming in IT roles. You'll be able to write simple programs using Python, figure out how the building blocks of programming fit together, and combine all this knowledge to solve a complex programming problem. That's right, by the end of this course, you're going to write a program in Python that's designed to solve a real-world IT problem. Super exciting, right? We'll start off by diving into the basics of writing a computer program. You'll quickly start to see how computers can perform a multitude of tasks. You just have to write code that tells them what to do. Along the way, we'll be talking about automation, which is the process of getting computers to automatically do a task that us humans normally have to do by hand. Now, some of this stuff can get a little complex and confusing. I promise to do my best to make these lessons clear and easy to understand. But if you get stuck at any point, please feel free to rewatch the videos. Practice as much as you like and take the time you really need to understand these topics. The goal of this course isn't to teach you everything there is to know about software engineering because, yikes, that would be a long course. Instead, we're going to introduce you to some of the key concepts of programming and scripting that will empower you to spot opportunities for automation in real life. You're about to learn a skill that can help you take your career to whole new levels. Are you excited? I'm excited. So let's jump in. Working in IT is more than just a job. It's a career path. Research shows that the field of IT support is a launchpad for future career growth and better wages. In fact, a study on the subject was recently conducted by the Harvard Business School, Accenture, and Burning Glass entitled Bridge the Gap. It found that among today's middle-skill jobs, which require training but not a formal college degree, IT support offers clear pathways to prosperity. We saw this phenomenon play out here at Google in our IT support program. Those who pushed themselves to learn how to code in Python typically saw strong career growth. They built skills that are critical to accessing higher-level positions in the IT field. And after honing those skills through hard work and determination, they advanced into more technical IT support specialists, systems administrators, technical solutions engineers, and even site reliability engineers. The common thread across all of these roles is knowing how to write code to solve problems and automate solutions. By expanding your toolbox to include coding skills, you open a window into the world of systems management that can lead you towards more advanced technical roles down the line. Python in particular is having a huge surge. According to the 2019 Stack Overflow Developer Survey, Python is the coding language most people want to learn, the second most loved by those who already know it, and the fourth most popular overall. So why take this program to learn how to code in Python? Well, first, it's geared towards people who are already in or aspiring to be in the field of IT. Maybe you're thinking bigger about your current IT role and want to work towards managing operations at scale. Or maybe you're just starting out and looking to break into the IT industry. Perhaps you've taken our IT Support Professional Certificate program on Coursera already. Or you have equivalent IT support knowledge with basic computing skills, like working with files and directories, familiarity with networking concepts, and understanding how to install software on your computer. In any case, this program is tailor-made for you. Second, this program offers 3 hands-on methods of teaching coding in Python and automation: Code Blocks, Jupyter Notebooks, and Quick Labs. And third, we've assembled an awesome group of Googlers who will serve as your instructors in each course. They all started their careers in IT support, then learned programming, and moved on to more technical roles, like me. We can't wait to share our stories with you and how we use Python in our day-to-day. Oh, and hey, I should probably introduce myself. My name is Christine Raffla, and I'm a systems administrator at Google. I will be your instructor in this course. This program has been entirely designed and developed by Google, and we even filmed each course at different cool Google spaces. It'll introduce you to the Python programming language with a special focus on how this language applies to automating tasks in the world of IT systems support and administration. I'm super excited to be here with you. When I was younger, I had no idea that careers in IT even existed. There are a lot of reasons I wanted to participate in this certificate program, but one of my biggest motivations is that I want to see more women represented in the industry. I remember going to a system administration summit where there were hundreds of men and about 3 women that were sysadmins. A lot has changed since then, but there's still so much we can do to bring new ideas and representation into the IT field. That's why I want to share my knowledge with as many people as possible. I love my job and I love the people I work with because they make it easy to ask for help and offer their guidance. This type of support network allows our team and ultimately our industry to be more successful. I understand from experience that it can feel pretty intimidating and maybe even a bit scary to learn a coding language. Just remember, everyone started where you are right now, with the first command, the first script, and of course the first of many errors. When I started out in my career, I strived to get everything perfectly right the first time I tried it, but that actually slowed down my progress. So don't be afraid to make mistakes. It will give you a leg up. So let's get down to it. What's ahead? The program begins with a crash course in Python where you will learn to write simple programs and understand their role in automation. Next, we'll get more hands-on focus on how Python interacts with the operating system. After that, we'll cover how to use Git and GitHub to manage versions of your code. Then, we will focus on troubleshooting and debugging techniques to find and solve the root cause of problems in IT infrastructure. The next course covers automating at scale, where you will learn to deploy configuration management on a fleet of either physical or virtual machines running in the cloud. And last up, we will bring all this knowledge together and complete a final project designed to solve tasks that you might encounter in real-world IT settings. Bonus, you can post your projects to GitHub to show off your fancy new skills to employers or friends, or both. Phew, that was a lot to rattle off. Are you excited or what? Now I'd like to quickly introduce you to my fellow instructors who you will get to meet along the way.
Hey, my name is Roger Martinez. I'm a Linux system administrator, and I'll be your instructor in the course on using Python to interact with the operating system.
Hi, I'm Kenny Suleiman, and I will be your guide in the course about using Git and GitHub to manage versions of your code.
Hi there, I'm Amanda Bellis, and I'll be teaching you about troubleshooting and debugging.
Hey, I'm Phelan Vendeville, and in my course we'll learn about automation at scale using configuration management and the cloud.
Thanks, everyone. This all-star team was brought together to guide you on your adventures in coding. You're in very good hands. Okay, I think that's everything. Let's get ready to learn some new skills and maybe even have some laughs along the way. I'll see you in the next video. At a basic level, a computer program is a recipe of instructions that tells your computer what to do. When you write a program, you create a step-by-step recipe of what needs to be done to complete a task. And when your computer executes the program, it reads what you wrote and follows your instructions to the letter. How nice is that? The recipe is written in a code called programming language. Programming languages are actually similar to human spoken languages since they have a syntax and semantics. Now, if it's been a while since your last grammar class, here's a quick refresher on syntax and semantics. In a human language, syntax is the rules for how a sentence is constructed, while semantics refers to the actual meaning of the statements. In English, sentences generally have both a subject, that's a person, place, or thing, and a predicate, usually a verb, and a statement that explains what the subject is doing. Let's take the sentence, Paula loves to program in Python, as an example. In this sentence, Paula is the subject, and loves to program in Python is the predicate. To form a sentence that others can understand, you need to know both the syntax that constructs the sentence and the semantics that gives it meaning. The same applies to programming languages. In a programming language like Python, the syntax is the rules for how each instruction is written, and the semantics is the effects the instructions have. Much like spoken languages, there are lots of programming languages to choose from. Each has its own history, features, and applications. But they all share the same fundamental ideas, so once you understand the basic concepts in one programming language, it becomes much easier to learn another. And lastly, computers always do exactly what they're told. So when you write a program, it's important to be super clear about what you want the computer to do. Learning the syntax and semantics of the programming language you choose will allow you to do just that. Make sense? Before we continue, let's spend a moment on terminology. In the next few videos, you'll hear the term script being used a bunch. So what's the difference between a script and a program? The line between the two can be a bit blurry, and in this course, we'll use the terms interchangeably. In general, you can think of scripts as programs with a short development cycle that can be created and deployed rapidly. In other words, a script is a program that is short, simple, and can be written very quickly. In this course, we'll focus on a specific scripting language called Python, which we'll use to learn the basics of programming. We'll learn about the Python syntax, the rules of how to write a Python program, and the semantics, or meaning, of the different pieces involved. Before we start learning how to code and having you write your first Python script, let's talk more about what automation is and why it's useful. Although we might not realize it, we reap the benefits of automation all the time in our daily lives. Do you ever pay your bills with scheduled payments or use a self-checkout at the grocery store? I always set my coffee machine to start brewing before I've even gotten out of bed. The promise of fresh coffee makes early mornings way easier. Automation is the process of replacing a manual step with one that happens automatically. Take a traffic light, for example, which continuously regulates the flow of vehicles at an intersection. A traffic light requires a human intervention only when it needs repairs or maintenance. The automatic regulation of traffic means that humans don't have to stand at the intersection manually signaling when cars should stop or go. Instead, people can concentrate on more complex, creative, or difficult tasks like focusing on where you're driving. What's more, traffic lights don't get tired, bored, or accidentally display a green light when they met red. This highlights another benefit of automation: consistency. Let's face it, us humans are flawed and sometimes we make mistakes. A human performing the same task hundreds of times will never be as consistent as a machine doing the same thing. But for all of its advantages, automation isn't a solution for every situation. Some tasks just aren't suited for automation. For example, they may require a degree of creativity or flexibility that automatic systems can't provide. Or, for more complicated or less frequently executed tasks, creating the automation may actually be more effort or cost than it's worth. Think about when you get a haircut. What would it take to automate the actions of cutting hair with a machine? The client's height, the shape of their head, their current hair length, and desired hairstyle would all need to be taken into account when designing the automatic system. We'd need to replicate the creativity and skills of a trained specialist, along with extensive testing to ensure the client's safety and quality haircut. And if you've ever had a bad experience at a hair salon, you know quality can be subjective. In this case, the cost and effort of automation just isn't worth the benefits of an automatic haircut would provide, which is why we don't have robot hairstylists. Not too complex, right? Automation is a powerful tool when used in the right place at the right moment. It can save time, reduce errors, increase consistency, and provide a way to centralize solutions and mistakes, making them easier to fix. Throughout this course, and in upcoming ones, we'll be talking about when it makes sense to apply automation and exactly how you do it. Eventually, knowing when and where to use automation will become automatic for you. Working in IT, a lot of what we do boils down to using a computer to perform a certain task. In your job, you might create user accounts, configure the network, install software, back up existing data, or execute a whole range of other computer-based tasks from day to day. Back in my first IT job, I realized that every day I came into work, I typed the same 3 commands to authenticate into systems. Those credentials timed out every day by design for security reasons. So I created a script that would automatically run these commands for me every morning to avoid having to type them myself. Funny enough, the team that monitors anomalous activity discovered my little invention and contacted me to remove it. Oops. Tasks performed by a computer that need to be done multiple times with little variation are really well suited for automation. Because when you automate a task, you avoid the possibility of human errors and reduce the time it takes to do it. Imagine this scenario. Your company had a booth at a recent conference and has gathered a huge list of emails from people interested in learning more about your products. You want to send these people your monthly email newsletter, but some of the people on the list are already subscribed to receive it. So how do you make sure everyone receives your newsletter without accidentally sending it to the same person twice? Well, you could manually check each email address one by one to make sure you only add new ones to the list. Sounds boring and inefficient, right? It could be, and it's also more error-prone. You might accidentally miss new emails or add emails that were already there. Or it might get so boring you fall asleep at your desk. Even your automated coffee machine won't help you out there. So, what could you do instead? You could get the computer to do the work for you. You could write a program that checks for duplicates and then adds each new email to the list. Your computer will do exactly as it's told, no matter how many emails there are in the list. So it won't get tired or make any mistakes. Even better, once you've written the program, you can use the same code in the future situations, saving you even more time. Pretty cool, right? It gets better. Think about when you're going to send these emails out. If you send them out manually, you'll have to send the same email to everybody. Personalizing the emails would be way too much manual work. If instead you use automation to send them, you could have the name and company of each person added to the email automatically. The result? More effective emails without you spending hours inserting names into the text. Automating tasks allows you to focus on projects that are a better use of your time, letting computers do the boring stuff for you. Learning how to program is the first step to being able to do this. If you want to get computers to do the work for you, you're in the right place. Earlier in this video, I told you about the first task I ever automated, Now I want to tell you about the coolest thing I ever automated. It was a script that changed a bunch of access permissions for a whole lot of Google internal services. The script traversed a large directory tree with tons of different files, checked the file contents, and then updated the permissions to the services based on the conditions that I laid out in the script. Okay, I admit I'm a total nerd, but I still think it's really cool. Make sure you read what others are saying. They may give you ideas that you haven't even thought of. After that, you're ready to take your very first quiz of the course. Don't worry, it's just for practice. Welcome back. How'd you do on your first quiz? If you got most of the questions right, great job. If not, no worries. It's all part of learning. We'll be here to help you check that you've really got your head around these concepts with regular quizzes like this. If you ever find a question tricky, go back and review the videos and then try the quiz again. You want to feel super comfortable with what you've learned before jumping into the next lesson. Remember, take your time. I'll be here whenever you're ready to move on. Okay, feeling good? Great, let's dive in. In this course, we'll use the Python programming language to demonstrate basic programming concepts and how to apply them to writing scripts. We mentioned that there are a bunch of programming languages out there. So why pick Python? Well, we chose Python for a few reasons. First off, programming in Python usually feels similar to using a human language. This is because Python makes it easy to express what we want to do with syntax that's easy to read and write. Check out this example. There's a lot to unpack here, so don't worry if you don't understand it right away. We'll get into the nitty-gritty details later in the course. But even if you've never seen a line of code before, you might be able to guess what this code does. It defines a list with names of friends and then creates a greeting for each name in the list. Now it's your turn to make friends with Python. Try it out and see what happens. Throughout this course, you'll execute Python code using your web browser. We'll start with some small coding exercises using code blocks, just like the one you experimented with. Later on, as you develop your skills, you'll work on larger, more complex coding exercises using other tools. Getting good at something takes a whole lot of practice, and programming in Python is no different. We recommend that you practice every example we share in this course on your own. If you don't have Python installed on your machine, no worries. You can still practice using an online Python interpreter. Check out the next reading for links to the most popular Python interpreters available online. Now, I'm sure you're wondering, what the heck is a Python interpreter? In programming, an interpreter is the program that reads and executes code. Remember how we said a computer program is like a recipe with step-by-step instructions? Well, if your recipe is written in Python, the Python interpreter is the program that reads what's in the recipe and translates it into instructions for your computer to follow. Eventually, you'll want to install Python on your computer so you can run it locally and experiment with it as much as you like. We'll guide you through how to install Python in the upcoming course, but you don't have to have it installed to get your first taste of Python. You can practice with the quizzes we provide and with the online interpreters and code pads that we'll give you links to in the next reading. We'll provide a whole bunch of exercises for you, but feel free to come up with your own and share them in the discussion forums. Feel free to get creative. This is your chance to show off your new skills. Remember how we mentioned that Python is simple and easy to use? Python makes it easy to express the fundamental concepts of programming, like data structures and algorithms, with easy-to-read syntax. This makes Python a great language to use to learn programming. And there are other reasons to pick Python too. Python is super popular in the IT industry, making it one of the most common programming languages used today. Python isn't new. Its first version was released by Guido van Rossum back in 1991. Since then, the community that develops it has grown and the language has advanced a lot. Whenever there's a significant change to the semantics or syntax of the language, a new major version is released. In 2000, Python 2 was released. In 2008, we got Python 3. In this course, we'll use Python 3.7, which came out in 2018. For many years, Python was considered a beginner's language and was mostly used for teaching concepts or writing very small, simple scripts, like in this course. But in recent years, the adoption of Python has grown dramatically. One reason for this is that the language has become more powerful. It's also because there's more tools available in Python for a growing range of applications. You can use Python to calculate statistics, run your e-commerce site, process images, interact with web services, and do a whole host of other tasks. Python is perfect for automation. It lets you automate everyday tasks by writing simple scripts that are easy to understand and easy to maintain. That's why Python is the language of choice for lots of people working in IT support, system administration, and web development. Not only that, but it's also used in fast-growing areas of IT like machine learning or data analytics. Last but not least, Python is available for download on a wide variety of operating systems like Windows, Linux, and Mac OS. And what's more, Python is so popular in the workplace that if you are currently working in IT, you've most likely encountered it already. And if you're planning for a career in IT, chances are you'll interact with Python quite a bit. So, there's a whole lot of reasons for why Python is relevant to today's IT industry. A large part of programming is learning through trial and error and asking questions. So if at any point you get stuck, don't get discouraged. Making mistakes helps you improve. The more you see failure or broken code as an opportunity to learn, the quicker you'll master programming. I remember the first Python script I ever wrote. It took a lot of refactoring, debugging, and testing to get it to work. I relied on a lot of my teammates for help and mentorship and wound up spending more time on Stack Overflow than actually writing the code. Thankfully, you don't have to reinvent the wheel. There's almost always someone on the internet who's tried to do what you're doing and can help point you in the right direction when you're stuck. Sometimes it takes a village. It's really important to keep in mind that even experienced programmers may need to ask a colleague a question from time to time, or look something up on the internet. Whether you're a programming novice or have some experience in software development, remember, the best programmers overcome challenges by seeking help or using other resources. Once you've completed this program, you'll be well on your way to confidently programming in basic Python. There's lots of information online that will help you continue to develop your programming skills. For example, there are lots of online courses for specific programming languages. You'll find answers to your Python coding questions in the official Python documentation. You can use sites like Stack Overflow to discuss and share with other developers. You can even subscribe to some of the Python mailing lists to keep in the know on the latest updates to the language. You're opening the door to the whole world of programming, and it's super exciting to be joining the development community. The most important thing to remember is that you're never alone. Any questions you may have, any time in your career, there are resources out there to help you find the answers you need. Wow, that was a lot of information. Feel free to take a quick break, grab something to drink, and then head on over to the supplemental reading to learn more about Python and the resources out there to help you learn. Although we picked Python for this course, it's important to note that it's just one of the many coding languages out there. Think of a given programming language as just one of the many powerful tools in your IT toolbox. Each language has its unique set of pros and cons. Some run faster than others, some are better suited for enterprise applications, others are particularly good at crunching numbers. There are platform-specific scripting languages like PowerShell, which is used on Windows, and Bash, which is used on Linux. Both are widely used by system administrators on those platforms. There are also general-purpose scripting languages similar to Python, like Perl or Ruby, which are also widely used for scripting and automation. JavaScript, which was originally developed as a client-side scripting language for the web, is increasingly used as server-side for a broader set of tasks. And the list doesn't stop there. There's a vast array of traditional languages to explore, like C, C++, Java, or Go. As you progress in your career in IT, you'll probably encounter a number of different languages and learn when to use each of them. But let's not get ahead of ourselves. First, we have Python to get our heads around. A nice feature of learning the basics of programming in one language is that you can generally apply the same concepts you learn to other languages. This means that once you're familiar with Python, you'll find it easier to pick up new coding languages, as you'll spot and understand similarities and differences between them. After all, every language needs to do some common things like create variables, control the flow of a program, read input, and display output, even if they do these tasks using different approaches. As we called out earlier, learning a programming language is somewhat similar to learning a foreign language. You'll need to grasp the syntax and semantics for that language. Luckily for us, once you know the fundamentals of programming, learning another language is much easier than learning a second foreign language. There are a lot more similarities between programming languages than differences. To explore some of the similarities and differences between various scripting languages, let's take a look at a simple program that prints the words "Hello World" 10 times in 3 different languages: Python, Bash, and PowerShell. As you can see, each language uses a different approach to printing "Hello World." But look closer and you'll see similarities too. Each language must somehow put text onto the screen. The command for Python is print. For bash, it's echo. And for PowerShell, it's write host. Also notice that each language has to count to 10 in some way. While Python does this by specifying range 10, bash uses a sequence notation to count from 1 to 10. PowerShell has the most complex syntax in this example, but it also boils down to starting at 1 and counting up to 10. So, as we've just seen, there's a whole lot of programming languages out there. But don't let that scare you. In this course, you will only need to focus on learning Python. Once you can speak Python, you can go on to learn any other language you want. Up next, we've got another quiz to help you practice what you've just learned. Now that you've got an idea of what Python code looks like, let's check out one of the most basic examples and dive deeper into what's going on. Get ready. We're going to use a Python interpreter to make our computers say hello to the world. When we run this code, either locally on our machine or on a web interpreter, the words hello world appear on the screen, just like magic. Actually, it's not magic. It's because print is a Python function that writes what we tell it to on the screen. Like the statement hello world, for example. The print function is part of the basic Python language. Whenever we use keywords or functions that are part of the language, we're using the programming language's syntax to tell the computer what to do. So, what are functions and keywords? Functions are pieces of code that perform a unit of work. We'll talk a lot more about functions later on, and you'll even learn how to write your own. Keywords are reserved words that are used to construct instructions. These words are the core part of the language and can only be used in specific ways. Some examples include if, while, and for. We'll explain all of those and a bunch more later in the course. As we called out, the keywords and functions used in Python are what makes up the syntax of the language. Once we understand how they work, we can use them to construct more complex expressions that get the computer to do what we want it to do. Last off, notice how hello world is written between double quotation marks. Wrapping text in quotation marks indicates that the text is considered a string, which means it's text that will be manipulated by our script. In programming, any text that isn't inside quotation marks is considered part of the code. Now for a bit of trivia. Do you know why we greeted the whole world in our example? Well, printing hello world has been the traditional way to start learning a programming language since way back in the 70s when it was used as the first example in a famous programming book called the C programming language. That example looked like this. In Python, the hello world example is just one line. In C, it's 3 lines. In other languages, it could be even more. While learning to write hello world won't teach you the whole language, it gives you a first impression of how functions are used and how a program written in that language looks. All right, now that we've written our first piece of Python code, I think you're ready for something a bit more challenging than hello world. Ready? Let's do it. On the whole, for a program to be useful, it needs to get at least some information from the user. With this data, the program can take actions that are relevant to the user instead of generic actions like printing hello world. Data can be provided to a computer in a bunch of different ways. For example, on a website, you might input data by entering text into text fields or clicking links. If you're using a mobile application, maybe you'll click on buttons or select preferences from a drop-down menu. In a command line program, you might provide additional data by passing strings as parameters to the program, or you could have the program ask you for data interactively. All these various platforms, programs, and apps process data differently. Some might take the contents of a file as data to be processed, others gather data from other sources and process it in the background. Remember our earlier example when we automated the process of identifying and removing duplicate emails? There, the data provided to the program was the list of emails, which would usually be given in a file that lists the emails one per line. Whichever way your application gets the data, it will need to come from somewhere. For our first examples in this course, we'll just have the data as its own line in our block of code. This is limited, but straightforward. Later in this course, and in upcoming courses, we'll introduce you to better ways of feeding data into your code. For now, though, let's see this idea in action in a very simple example. By having the name separate from the call to the print function, we're making the line of code that calls the print function generic, while still personalizing the greeting. If we then wanted to say hello to a different person, we only need to change the name, but the call to the print function will remain the same. Pretty simple, right? Next up, we'll learn a few other easy things that you can get Python to do for you. There's a ton of things that you could do with Python, and you'll learn many of them in this course. But before we dive into complex subjects, let's have some fun with another simple task that you could do with Python. We're going to make Python our calculator. And let's start with something easy. So, 4 plus 5 is 9. 9 times 7 is 63. Minus 1 divided by 4 is minus 0.25. Easy. Repeating or periodic numbers are printed in a longer format. Let's try 1 divided by 3. In math theory, when 1 is divided by 3, the digit 3 repeats forever after the decimal point. Of course, it's hard to display something that repeats forever, so instead we have a representation showing lots of decimal places. Not too hard, right? Let's give the computer something a bit trickier. Let's say we want to divide 2050 by 5, then subtract 32, and then divide the result by 9. To do this, we'll need to use parentheses, just as we do in typical math problems. You can also use Python to get squares, cubes, or any power of n of a number. For example, let's say we want to find out what 2 to the power of 10 is. To get Python to give us the answer, we use the double star operator. If you're starting to worry that this is becoming an algebra course, relax, we're not going to do anything more complex than what we've just seen. And if you're thinking, why would I use Python instead of just a normal calculator? That's a valid question. Experimenting in this way, you get familiar with the language's math capabilities. And in IT jobs, there are many tasks that require you to use math calculations. You might need to count how many times a certain word appears in a text, or work out the average time it takes for an operation to complete, or how much you have to compress an image to fit in certain size constraints. Whatever you need to calculate, writing a script can help you do it faster and with more accuracy. So you need to know what mathematical operations are available to you. Python actually has a lot more advanced numeric capabilities that are used for data analysis, statistics, machine learning, and other scientific applications. We won't get into these in this course, but if you want to learn more about them on your own, there's a wealth of online resources available. Next up, a cheat sheet to help you with programming concepts that we've just covered. And after that, it's time for another quiz. This time with a few small coding exercises. Remember, if something isn't clear, you can re-watch the videos as many times as you need. Ready? You've got this. Now that we've covered some Python coding basics, we'll introduce you to some of the coding tools. Coding tools can help you develop, write, debug, and visualize your code. In this video, we'll cover the basics of code editors and integrated development environments, or IDEs. Code editors are tools used to make writing code easier. With a code editor, you can write, debug, and execute programs in Python. Code editors provide features including syntax highlighting, automatic indentation, error checking, and autocompletion. Overall, code editors help define the code's structure and function. This allows you to write code more efficiently. They also make it easier to understand variables, commands, functions, and loops. VS Code, Jupyter Notebooks, and Colab are some of the code editors we will cover in the next few videos. IDEs have more features than code editors. The difference between a code editor and an IDE is that a code editor is like a text editor. IDEs provide direction in writing code and allow you to see how the code executes. You can think of a code editor like a landline phone. You can dial numbers and make phone calls with it. An IDE is more like a smartphone. You can still make phone calls, but it has additional features that allow you to make video calls, send text messages, browse the internet, and use lots of other applications. An IDE is a software tool that simplifies the process of creating a new software application. An IDE is a software application that provides comprehensive facilities for software development. IDEs always include a code editor. IDEs allow you to develop code more efficiently by bringing multiple tools into one environment. You'll be able to edit, build, test, and package all in one application. They also allow you to program applications more quickly without having to add manual integration and configuration. Coming up, we will cover idle. Idle is an IDE that comes with Python automatically. It's an excellent beginner-level IDE because it's very simple to use. It may not be great for larger projects, but it's excellent for getting to know how to use an IDE. Now, let's dive into some of the code editors and IDEs that you can use as you continue in your Python learning journey. Let's get started with our first coding tool. In this video, you'll learn how to write Python scripts at the command line along with the Python GUI idle. The command line is used to tell your computer what to do. You can use it to access servers, move files, change directories, and write scripts. In this video, we'll show you how to use the command line and idle on the Linux operating system. If you're using another operating system, you can refer to the reading titled Use the Command Line. Now let's go over the command line on Linux OS. Access the Linux terminal by clicking on it or using Ctrl-Alt-T. This will allow you to check for Python. Type Python. Python comes pre-installed on most Linux systems. If the command is not found, you can install Python by writing sudo apt install python 3. Next, it will ask you for your password. Type your password and press enter. Python version 3 will begin installation. Once installation is complete, you can begin writing Python code from the terminal. Simply type Python 3 to use the interactive mode. Let's try out interactive mode using a print statement. Type print hello world and press enter. You will see the output hello world. To exit interactive mode, we will type exit open parentheses, close parentheses. You can also write Python scripts using Linux with idle. Idle allows you to write Python scripts with ease on your local machine. Idle is an integrated development and learning environment for the Python programming language. Python idle is included with Python installations on Windows and Mac OS. You can download idle using your package manager on Linux. Python idle is an interactive interpreter or file editor that allows you to easily write Python scripts and programs. Idle provides syntax highlighting, code completion, and automatic indentation. To install idle on Linux, type sudo apt install idle. Once installation is complete, type idle to open the interpreter and begin coding. Now we can write a Python file. Once you've completed writing your Python code in the file, go to File, Save As. Give your Python file a name. In this example, we will name our file sum.py. Hit Save. To run the Python code in the file you saved, click Run Module from the menu, or press Enter. Now you know how to use the command line to begin writing Python code. Remember, whichever operating system you're using, you'll be able to run Python from the command line. Using a text editor like idle and running Python from the command line is best for executing and debugging individual scripts or .py files. Next, let's explore some other code editors and IDEs. I'll see you over in the next video. There are many different environments that you can use to write and run code. In this video, you'll learn more about Jupyter Lab and Jupyter Notebooks for writing, running, and debugging Python code. Jupyter Lab and Jupyter Notebooks are part of an open source project called Project Jupyter and are free to use. You can learn more about Project Jupyter at jupyter.org. Jupyter Lab is a web-based interface that allows you to use Jupyter Notebooks to write, run, and debug Python code. Jupyter Lab provides an online environment that allows you to run your code in the cloud. Jupyter Notebook can be used in the web-based interface through Jupyter Lab or on your local machine. Jupyter Notebook allows you to create text-based documents that contain live code blocks. You can write Python programs and scripts using Jupyter Notebooks and see how they execute all in one place. It's a great tool for creating and understanding the code you're writing because you can see your input and output all in one spot. This is what a basic Jupyter Notebook looks like. Next, we will cover how to use Jupyter Notebooks. One of the most popular ways to use Jupyter Notebooks is in the cloud-based environment. You can use this environment by visiting jupyter.org. Once you're at jupyter.org, you can get started. First, click Try, then select Jupyter Lab. To create a new notebook in the lab environment, add a new tab and select Python under Notebook. A new notebook will open up, and you can start writing and running Python code. Let's give it a try. You will write your code in the cell with the blue border. Let's use a print statement. Type print hello world in the cell. Next, we will run the code in the cell. To do this, we'll use the Run button located at the top of the toolbar. Click on Run, and your cell will execute. Your output should be Hello World. You can save your Jupyter Notebook by using the Save button that's also located in the top toolbar. Click Save and give your notebook file a name. For this example, I will name my file hello.ipynb. Also, if you would like to download your notebook, you can do that using the File menu located in the top left-hand corner. You can also use JupyterLab and Jupyter Notebooks on your local machine. You can do this by using the pip command from the Python terminal command line. To install JupyterLab, type pip install JupyterLab at the command line. Once it's installed, you can launch it by typing Jupyter-lab. To install Jupyter Notebooks, type pip install notebook at the command line. Once it's installed, you can launch it by typing Jupyter Notebook. JupyterLab and Jupyter Notebooks are great resources for writing Python code. To note, notebooks can also be shared and saved easily using email, GitHub, and Jupyter Notebook Viewer. There are also tons of resources on Jupyter Notebooks out there, so if you need more support, the Jupyter website is a great resource to dive deeper into. In the next video, we will go over Colab. This is a coding tool that is very similar to Jupyter Notebooks. Head over to the next video to learn more. Recently, we covered how to use Jupyter Notebooks. In this video, we will go over Colab notebooks. Colab notebooks are Jupyter notebooks that are hosted by Google's Colaboratory. In Colab, you can write and run Python code. In this video, you will learn more about how to use Colab and its features. Colab is a web-based platform that allows you to write and run Python code really quickly in Google Drive. It's free and ready to use with zero configuration required. You can simply visit colab.sandbox.google.com or search Google Colab to get started. Colab provides all of the functionality that Python offers. The cells within Colab can include code, text, and images. The code cells include executable code and rich text, which makes it easy to write and run code. Colab also makes it easy to include Markdown in your notebooks. This is a great feature for sharing notebooks because you can add headings, paragraphs, lists, mathematical formulas, and more. You can install Python packages using the pip command within the code cell. Colab notebooks can easily be shared with other collaborators too. Now let's go over how to use Colab. First, open Google Colab. Again, you can do this by visiting colab.sandbox.google.com. Go to File and click on New Notebook. Now you can begin writing your Python code. In the code cell, let's write a print statement that outputs your name. To run your code and see its execution, use the Run button to the left of the code cell. You can also give your coding project a name. At the top, you can change untitled.ipynb to something like name.ipynb. This will make it easier to find your code in the future. The great thing about Colab is that it automatically stores your notebooks in Google Drive. To find your notebooks, you can simply visit your Google Drive, type in Colab Notebooks in the search bar, and open up the folder titled Colab Notebooks. Here you will see all of the notebooks you've created. And that's how you use Colab. Pretty simple, right? I'm sure by now you're getting the hang of using these code editors. Let's move on to our final one, VS Code. I'll see you in the next video. Now that you're familiar with a few different coding tools, let's take a look at VS Code. VS Code is an open source code editor that includes developer tooling. It's similar to Jupyter Notebooks and Colab, but it includes more features. VS Code provides built-in support with IntelliSense code completion, an interactive debugger, and other build and scripting tools. VS Code has a simple layout that makes it easy to learn and use. Its intuitive features make it a great choice for coding in Python. To use VS Code for Python, you will need to have Python 3, VS Code, and the VS Code Python extension installed. In this video, we're going to show you how to do that. You can use VS Code on Windows, Mac, and Linux operating systems. For this video, we'll be using the Linux operating system. If you're using another operating system, we have provided a reading on using VS Code with the other operating systems that you could take a look at later on. Now let's get started. We'll start by opening a terminal window. Type the following command, python 3 -- version. If Python 3 is installed, the output will show the Python version that is installed on your computer. An example of what that output would look like is Python 3.10.12. If it is not installed, the output will return command not found. This means you will need to start by installing Python 3. To do this, go to your terminal. At the command line, you will type sudo apt install python 3 and press enter. It will prompt you to enter your password. Enter your password and it will begin installing. As Python 3 is installing, it may prompt you to continue by asking, do you want to continue? Yes/no. Select yes and press enter. Now Python 3 is installed and ready to go. Let's move on to VS Code. You can download VS Code at code.visualstudio.com/download. Here we're going to download the version that is compatible with Linux. Let's select the .deb version of VS Code. We will give it a second to finish downloading. Next, we're going to go back to the terminal. We will navigate to the Downloads folder. We will do this by typing cd downloads /. Then we'll use the ls command. This will list the Debian file we just downloaded. The name of the file you just downloaded will appear. Next, you will type sudo dpkg-i and the name of the file listed. Once that command is executed, Visual Studio Code is installed. To open up Visual Studio Code, we type code at the command line. And Visual Studio Code will open right up for us. The final step is setting up Python in VS Code. To do this, we will browse for extensions. To view extensions in VS Code, we will type Ctrl-Shift-X. This will show you a list of the most popular VS Code extensions on the VS Code Marketplace. You can search for Python using the search bar and click Install. Once it's done installing, it will give you the option to get started with Python development. We'll jump right in by selecting Create Python File. This will open up the code editor. Let's test it out with a simple statement. We're going to type print hello world into the new workspace. Next, click on Run to run the code. You will be prompted to name and save your file. Give your Python file a name and click Save. In this example, we will give our file the name helloworld.py. Your code will run and you will see its output here. Great job! Now, to summarize, VS Code is an extremely robust source code editor. It uses IntelliSense technology, which provides syntax highlighting and autocomplete for coding. VS Code allows you to debug right in the editor with its interactive console. Overall, VS Code is extremely interactive and customizable. There's also a large library of extensions that are easily integrated. Great job! That was a lot to cover. Feel free to review these videos as many times as you need to. And remember, one of the best ways to figure out which tools work best for you are to explore all the features they have to offer and practice using them. Congrats! You made it to the end of the first module. Great job! You've taken the first steps to learning a new programming language and growing your IT skill set. Getting there shows real determination and a will to learn. We've covered a lot of topics, and many might be new to you if you've never learned about programming before. You've discovered what scripting is, what the syntax and semantics of a programming language are all about, and how they relate to automation. We've got to grips with small blocks of Python code, talked about why Python is relevant to IT, and explored what other programming languages are available. We've had our first approach to how to input data and write a script that puts this data to use. And we've seen how you can use Python to perform typical math calculations. Not bad for your first Python steps, right? This is just the beginning of an exciting journey learning to code, and we hope you're eager to learn more. Coming up, get ready for your first graded assessment. These assessments help you check whether you've understood all the concepts and that you're ready to move on to the next stage. Now, don't worry, if at any point you're not sure about a question, you can always review the videos and readings to remind yourself of the answer. Remember that everybody learns at different speeds, so take your time, really get familiar with the concepts, and once you feel ready, the assessment is there waiting for you. I'll see you back here once you've nailed it.